Jai Hind everyone. So this is next lecture. So this is a lecture related to computer networks, BTech, CSE and allied branches for 6th semester. The code is BCS 603. So the topic is error correction and detection. So you all know what is error, and in computer networks, error is the, or in mathematics, error is the something has been changed. If this is the actual thing and this is what you received, the difference between the actual and you received is called the error. The difference between the actual one on the or the observed one is called the error. How can you detect it? If you are receiving something different that what you are sending, it means we are receiving some erroneous data. So if you are detecting, what are the different techniques to detect that particular thing? Because in computer network, everything you are receiving in digital form. Digital is 100101011010. So this is very important to detect the particular type of thing, that the signal you are receiving is erroneous signal or the original signal. Okay. So you can detect and also you can correct it at your own. If you are not able to correct it, you can simply ask the sender to send it once again. This is a simple solution. If you are not able to correct, just ask the sender to send it again. Okay. So the different types of error, what is redundancy, the detection versus correction, forward error correction versus retransmission, and modular arithmetic. So we will discuss few points here. There are two types of error there. One is a single bit error, another is burst error. Single bit error is what? If during data transmission, only one bit has been changed. So we can easily detect this particular single bit error, and we can easily correct it if there is only one bit error. But if more than one bit errors are there, then it is not easy to detect it. If we are not able to detect it, we cannot correct it. So what will happen? We just ask the sender to deliver it again. So forward error correction versus retransmission. Forward error correction is the, we can detect and correct the error, but if we are not able to correct, we are not receiving the actual signal, we can just ask the sender to send it again. Okay. Detection and correction. If we are able to detect this is erroneous data, this is detection. And if you are correcting it, what the sender sent, if you are matching the data, if you are matched with the data, this is a correction. Redundancy. The redundancy are some duplicate bits that you can apply just to detect or correct the errors. So redundancy bits are very important, because this is the game. This is the redundant bits are the most important, very main thing with the data you are sending, that can help you in detection and correction. So, okay. So in a single bit error, only one bit in the data has been changed. Like for example, if this is the data and this one bit has been changed during the data transmission, so this is called single bit error. Burst error means two or more than two bits has been changed during data transmission. It is called burst error. So what will happen in this case? There are more than two bits has been changed during data transmission. Listen carefully. 0 to 1, 0 to 1, 0 to 1, 0 to 2. If there is 1, it can be 0. The data can be changed. If this is 1, we can receive 0. This is also. So do not misunderstand that every time the 0 has been become 1. No, 1 can be become 0. So this is the burst error. To detect or correct the error, we need to apply or to send some extra bits that can be treated as redundant bit or duplicate bit. So this is very, very important, because this redundant bit help you in detecting and also correcting the error in the data what you received. So this is the structure of encoder and decoder. Like for example, message, generator, message and redundancy. Unreliable transmission through any communication media. All communication channels are the unreliable transmission because some distortion, some attenuation, some noise has been added, your data has been changed during the data transmission, some hackers are there. So this is unreliable transmission. So what you receive the information, check and the message, correct and discard, correct or discard. If the data is correct, you can easily receive the data. If it is erroneous or it is different from what the sender sent, you just discard the message. Okay. So block coding. In block coding, we divide our message into blocks, each of k bit called the data word. And we can add R redundant bits. R, it means few redundant bits, maybe one, maybe more than one, that can make the length of data word k plus R. The resulting and bits block are called code word. Now it become code word. Data word is the actual data you are sending. Code word is the data that is transmitting through the communication channel with some redundant bits. This is code word. Okay. So 2 to the power k data words of k bits, and this is the 2 to the power n code word. Each of bits, only 2 to the power k of them are valid only. So the Hamming distance between two words is the number of differences between corresponding bits. For example, the Hamming distance 000 and 001 is 2 because the original one is this and the received is this. The 2-bit has been changed. How can you check that 2-bit had been changed? Just simply 000 001. Apply the XOR gate 011. Apply the XOR gate 110. So the number of bits has been changed is 2. 2 ones are there. So it means 2-bit has been changed. Another example is there. This is 10101, 10101. This is the sender data and this is the receiver data 11110. XOR gate. Apply the XOR gate 11010. How many ones are there? 3 ones are there. So Hamming distance becomes 3 because 3 ones are there by applying ones. So this is the error. Error is the difference between the actual data and the observed data. Difference between the sending, what the sender sent, or what you received. So if there is some difference, you can identify the difference by using XOR gate. This is the original one and this is the received one. If you getting all 0, there is no difference. You are receiving the exactly same. If you identify that some ones are there, count the number of ones. These are the error. If this is more than 1, then it is called burst error. If this is 1, then it is single bit error. Okay. So minimum Hamming distance is the smallest Hamming distance between all possible pairs in the set of words. Okay. A simply parity bit check code can be detect an odd number of errors. This is the first method to detect and correct the error. Okay. So how can you apply? Let's say this is the data 1, 2, 3, 4, 5, 6, 7. There is one question in my mind that on a keyboard there are different characters are there and every character can be recognized as a 8-bit because the length of a character is 8-bit. 1 byte is equal to 8-bit or 1 byte is equal to 1 character. Okay. But in ASCII code, the ASCII code length is only 7-bit. And you all know very well that capital A is treated as a 65 and it can be represented in a 7-bit only. So what about the 8-bit? This 8th bit is the redundant bit and 8th bit is treated as the parity bit. Okay. So parity bit always applied at the right hand side, not the left hand side. Because if you apply parity bit at the left hand side, it can be treated as either this is the positive number or the negative number. So keep in mind, if any bit applied in the left hand side, it can be identified as that whether number is positive or negative. So you can apply the parity bit at the right hand side. How can you apply the odd parity? Like for example, there are number of ones 1, 2, 3, 4, 5. Number of ones 5. Number of becomes should be even. So make it 1. If you are sending another data, that is this one 1, 2, 3, 4, then put parity bit as a 0. Here parity bit is 1, here parity bit is 0. So in the both cases, the number of ones are even. Now, this is transmitted through a communication channel. This is also transmitted through a communication channel. What you received? And in this, now what will happen? In this scenario, you can easily check number of ones become odd, 5 ones, but you send number of ones even. And in this case, number of ones are even, but in this case also, number of ones becomes odd. So it means there are some error. There is some error. So you need to correct or compare with the original data to detect the error, and then you can easily correct the error. Okay. Cyclic code are special linear block codes with one extra property. In the cyclic code, if a code word cyclic shifted, the result is another code word. Like for example, take another one example. This is a divisor. Okay. This is your data. Okay. Your data is, your divisor is 4-bit. Divisor is 4-bit. These are the redundant bit. So redundant bit is equals to the number of bits in divisor minus 1. If the number of bits in divisor is 4, then you can simply apply 3 redundant bits are there. Okay. You simply divide the data with the divisor. But one thing is there, that if you are minusing, if you are solving this one, you can apply the XOR gate here. Every time you are applying the XOR gate. Whatever you received in the last, this is remainder. You can simply replace this particular redundant bit with this remainder. Now the data becomes 1001, the actual data. This is the data word. Data word. You have applied some redundant bits and then find some remainder. The remainder you can put along with the data. This is the code word. Okay. So this is the method of CRC, cyclic redundancy check. Okay. So we will repeat it again in the next example. Now this one. Check it once again. This is 1011, 1001 and 110 is the code word. So you can divide it again, 1001, 110 by using 1011. Now the remainder becomes 0. It means you are receiving the error-free data, but if the remainder is there, if there is remainder, so it means there is some error. If there is some error, you can simply discard the data. In these two cases, this is the code word you received or this is the code word you received. In this code word, this 0 has been changed because in original one, this is 1 and what you received is 0. So there is some remainder. It means you are receiving some erroneous data. You can simply reject the data, just discard it, and you need to ask the sender to send it again. But if you calculating it and you receive the 0, then it means this is error-free data. Now, if you are dividing 1011, just simply applying XOR gate, 1 plus 1, 0, carry 1, no. Simply XOR. XOR means if both bits are different, put it 1. If both bits are same, put it 0. 1, 1, 0, 0, 1 different, 1, 0, 0, 0. 1, 1, 0, okay. Then 1, put it 1 from here. Again, because there are 3 bits only and there are 4 bits, you cannot apply XOR gate. So another one has been there, 1011, 1011, then again 0, this is 0. So there are rules. This method can be done using this polynomial generator also. X to the power 3 plus 1, it means, like for example, 1, 0, 1, 1, 0, 1. This is x. This is x to the power 0, 1, 2, 3, 4, 5, and so on. This is 1, so it means multiplied 1. This is multiplied by 0. This is multiplied by 1. This is multiplied by 1. This is multiplied by 0. This is multiplied by 1. So what will there? X to the power 5 plus x to the power 3 plus x to the power 2 plus x. Plus x. This is how you can convert your binary into polynomial form. Okay. So this is the case where the polynomial terms can be converted into binary term. Like for example, if this is, so if you are converting this, so 1, 1, 0, 1, 2, 3, this, 1, 0, 1, 1. Okay, this is a divisor. If you are converting this into binary, then you can convert in this way. So, which of the following GX value guarantee that a single bit error can be caught? For such, what is the error cannot be caught? These are 3 examples. X to the power I can be divisible by x plus 1. So, any single bit error can be caught. Second case, x to the power 3. If I is equals to the greater than 3, then x to the power I is divisible by gx. All the single bit error at the position 1, 2, 3 can be caught. And in the third case, all value of I makes x to the power I divisible by gx. So this is not the case. No single bit error can be detected. So this one cannot be the divisor. These are the polynomial generator. So find which is the best one. The first one, x plus 1. This is a very poor choice of generator. Any 2 error next to each other cannot be detected. X to the 4 plus 1. This generator cannot detect 2 error. There are 4 position apart because 1, 0, 0, 0, 0, 1. So it is not possible. X to the power 7 plus x to the power 6 plus 1. This is also not the good. This can be the good choice because x to the power 7, x to the power 6 and 1, there are 3 points are there, 3 ones are there, and you can use this one also. X to the power 15 plus x to the power 14 plus 1, this is very long one. So if there are very long data, then you can use this one, otherwise you cannot use the part D. A generator that contain a factor of x plus 1 can detect all odd number of errors. Like x to the power 6 plus 1 can detect all burst error with the length less than or equals to 6 bit. 3 out of 100 burst error with the length 7 will slip by. 16 out of 1000 burst error of length 8 or more will slip by. Okay. So a good polynomial generator needs to have the following characteristics. What are the different following characteristics? It should have 2 terms. Number 1, this is very important because in many examinations, this particular type of question has been asked that what are the points or how can you identify that this is a good polynomial generator? The first point, it should have at least 2 terms. The coefficient of the terms x to the power 0 should be 1. X to the power 0 always treated as 1. It should not divide x to the power t plus 1 for t between 2 to the power n minus 1. And last, it should have a factor of x plus 1. These 4 conditions are the necessary requirement to have a good polynomial generator. If you fails to follow these 4, the polynomial generator is not able to find all types of errors. Now the checksum. Checksum is very easy, but this checksum can be used in many of the cases, in many of the frame formats. If you study ARP, if you study IP, if you study TCP, the checksum is used. Checksum is what? Checksum is the detecting method where the simple data and the ones complement of data can be added to the data, and the code word is, if you are adding ones complement of this, what you received, just 1 1 1 1 1 1. It means the code word is the actual data along with the all ones, so that if you are again adding this one, the final data becomes 0. Like in this case, let's take another one example. Take this one. Okay. So this is the data. Sum is 36 because this is a single bit. So checksum is 9, 9, 6, 15 because in hexadecimal code. So 36 become this. This 10 because we are converted into 4-bit only. So 10 added to the right hand side. So this is 9 and this is 6. 9 is the detail of wrapping and completing this one in this case. Okay. So how can you find the checksum? Checksum is at the receiver side, you can see sum is 45, wrapped sum is 15, and the checksum is become 0. Here is checksum is 9. Now the checksum is 0. Check this one. Let's say, for example, FORO use at AN. Forwarding is the word that you are sending from one device to another device. This FO can be read into this one. FO, this one. 4666F. How can you read it? This is in, it means some ASCII characters, and ASCII character you are converted into hexadecimal code. So if you are converted in hexadecimal code, it becomes 466F. Similarly, RO is this, UZ is this, AN is this. Okay. Checksum initially is 000 because there is no error. And if you are adding this one, then it becomes 8FC6 and 1 is the carry. So carry has been added to this side. So this is the sum finally. And ones complement, this is 7038. This is the ones complement. You are sending this one 3038. So what you will receive? You receive FFF E plus 1 and FFFF. Okay. So this is a checksum method. You can apply everything. So that's enough for this.